Okay, next Tuesday, they will be having this event. Okay, and we need support from the student to join the event. So before our class next Tuesday, please join this event where lunch will be provided. Okay, starting from you can join at 10 a.m. until 12. So this once you join this event, attendance will be considered for the class. Okay, because our class on next coming Tuesday will be offline. Okay, so attendance for Tuesday class is considered once you join this event. Okay, and then I will post one exercise for that Tuesday class as well. Okay, so please join this. I will share in the CN on the details. Location GGO8 downstairs. Okay, please join 10 a.m. up to lunch hour. After 2, do you have any class? So if you are still interested to join the forum, you may join this until the end of the session. They will have a forum on the roadmap drive to the future sustainable bioenergy. Okay, so bioenergy related to bioenergy. Since it is related to bioenergy, somehow related to our course as well. Okay, this one with University of Cambridge. Collaboration UCSI and University of Cambridge. Okay, can I will share the detail in CN. Okay, next we continue on our class or lecture for sustainable fuels. Once again, I have posted test date, which is on 28, 2 weeks, 28 during class hour. Okay, and the topics covered is CO3, which involve the adiabatic flame temperature, combustion monitoring, and water gas shift reaction. And then sustainable fuels. Okay, this topic. What else? And again, by today, I will release assignment. Okay, most probably by today. The latest will be tomorrow. What else? Okay, I think that's all for the announcement. Okay, now we proceed with our sustainable fuel. Last class, we had gone through what is the type of first generation and second generation of biofuels. Okay, we know first generation is from food source. Okay, the first generation food source. Second generation is after they have fulfilled the food purpose. That means second generation we can say using the waste. Okay, gasification. What do you understand from the gasification process? I believe in your PDP there are some process using gasification process. Any idea what is it? What is the production and the product of the gasification process? Gas. What kind of gas? It's called a syngas or producer gas. Okay. Okay, in the first place, why do you need this syngas? Okay, gasification, it means incomplete combustion. It involves incomplete combustion. We know in incomplete combustion, you will have CO H2 and traces of methane, and perhaps traces of your fuel, soot, carbon. Okay. Now, purpose to use this gasification process is to obtain the H2 and CH4 gas. Okay, this is flammable gas, which can be used as fuel into other types of process, perhaps power plant. Okay, these gases called as producer gas or syngas. In gasification, partial combustion of solid fuel. Most of the time, it is solid fuel, biomass or coal. Okay, and take place at temperature of around this degree at high temperature. The reactor called as gasifier. Gasifier also it has few types of gasifier. In industry, there are few types. Okay, the key to gasifier design is to create conditions such as that biomass is reduced to charcoal, then the charcoal converted to CO and H2 at a suitable temperature. Okay, so the design, they want the biomass to be reduced to charcoal, where then this charcoal is converted into CO and H2. If you use a furnace or a combustion chamber, the biomass will be burned completely to form CO2 and H2O. Okay, the purpose of furnace to have a complete combustion. If you require your gas is H2, so you will need to use gasifier. Okay, the combustible gases from gasifier can be used in internal combustion engines, direct heat applications, and also as the feedstock for the production of chemicals such as methanol. Okay, so methanol, this is where methane comes in, where you need the methane. And this H2 also, okay, methane you can use to produce methanol as fuel for combustion. Okay, H2 can be used as fuel as well because it is flammable and fuel to combustion. And this H2 is used as fuel to fuel cell. Where fuel cell, the later topic on the fuel cell, H2 is supplied to the fuel cell system. H2 plus O2, then you will have electricity. Okay, the on the fuel cell. So the source of H2 to be used to fuel cell can be produced from gasification process. Okay, previous semester there are one question asking to describe or explain what is the fuel to be used for fuel cell and where can you obtain the fuel. So that question is focusing on the H2 production. Where can you get the H2? Okay. Now there are various types of gasifier. We have updraft, downdraft, and crossdraft. The difference is on the air inlet. Updraft, the air will go from the bottom and it will flow upwards. Okay, this is the biomass. This is a solid biomass. Okay. Air flow from the bottom, flow upward. Then here it occurs all the process, the combustion, the pyrolysis, the reduction. Okay, the next slide, you will see the detailed process inside the gasifier. For the downdraft, air inlet is in the middle of the gasifier, where the air, when it enter the gasifier, it will go downward first. Go downward, then only it will flow upward. The cross draft, it is opposite on the outlet with the gas outlet. Air enter on bottom over here. The gas, okay, here it will flow inside the gasifier. Then the gas will go up over here. Cross draft. Okay, so you should, perhaps you can find out in the journals or in the website of any industry the types of gasifier used in the industry. And their advantage. Okay, so among these three, try to look out which one is more suitable to be used, more economical to be used. Okay, in terms of, you find out the advantage. In terms of sustainable application, economic, here it can be from the design as well, design and costing. Okay, and ease of maintenance. Okay, these three, you might want to look into it. From these three types of gasifiers, so which one can be used, which one can be considered as a sustainable gasifier in terms of the economic, perhaps impact to the environment, if there is impact to the environment from the three different types. Okay. Okay, these are the process zone in updraft. Okay, I use example of updraft gasifier. The air inlet from the bottom will flow upward. This down here is the ash pit. In here, okay, in here, all the biomass. Combustion zone over here. So here is combustion zone. Notice the temperature level. Okay, the temperature range over here on the combustion zone. So once the biomass combusted, it will produce CO2, CO, H2O. Okay, and ash. That's why here, down here, you have ash pit. Okay, as it goes upward, here is reduction zone. Notice the degree, the temperature is reducing as it goes upward. Okay, reduction zone, pyrolysis zone, drying zone. Drying zone, we know here it will remove moisture. Main purpose to remove moisture. Okay, the rest of the zone in the next slide will be the details. Okay, here gas will flow out on top of here. So here the gas will be CO, H2, CH4. You have also CO2. H2O in gas form. Okay, the temperature range here you should take note as well, because each zone has their own temperature range. Now this one is combustion zone. Okay, combustion process. In complete combustion, CO2 is obtained. CO2 and water. Okay, so the combustion reaction is exothermic and yields geological oxidation temperature around this temperature. The main reaction for the combustion zone, as I deleted the title, here is the combustion zone. Description for combustion zone. So this is what happened in the combustion zone. Carbon from the biomass react with the air, okay, complete combustion, then you will have CO2 and H2O. These are the gases produced from the combustion zone. CO2, H2O. Okay, moving upward. Let me make the image bigger. Moving to the next zone, which is reduction zone. Okay, reduction zone. This part, it produces CO, H2, methane, and some of H2O. Okay, the products of partial combustion. So for the reduction zone, these are the gases produced. You will have CO, H2, CH4, H2O. Okay. Now the temperature range is between 900 to 600 to 900. The temperature range. Now here comes the pyrolysis zone. The pyrolysis zone, the temperature range around from 400 to 600. In this zone, it will produce large quantities of tar and gases containing CO2. Okay. You will have also methyl alcohols, methanols. So here you have tar, CO2, some of methanol, small percentage of H2. Okay, this tar is in liquid form. If you read through few journals, For the pyrolysis process is the process that they use to produce bio-oil. Okay, if you have heard bio-oil, so it comes from the pyrolysis process. They use pyrolysis process. The temperature is between 400 to 600. Okay, now the drying zone. As we know, drying mainly to remove the moisture. The temperature range around this figure. Okay, so we have combustion zone, reduction, pyrolysis, and drying zone. Any question? From the biomass, enter gasifier, you will have CO, CO2, H2O, H2, CH4. This is gas. Some of methanol, some percentage of methanol from the pyrolysis zone just now. Okay, and the liquid you have the tar or bio oil. Charcoal is for the solid product. Okay. Okay, let's say for the gas, these are the gases released. But you only need H2, for example. What you need to do to purify the hydrogen? They will involve several units of, because you need to remove all those gases, CO, CH4. Yes, if contains methanol, then you need to figure out how to remove those. Okay, all of this in gas form. So you need to think, how can you purify only H2? Let's say you want to use H2 into your fuel cell. So how to get that only H2? Okay, try to read some journals on how to get those H2. Okay, this gasifier conversion efficiency. For the efficiency, basically, these are the equation where it involves the CV of the gas of fuel, CV of the fuel, and over average CV of 1 kg of fuel. Okay, the gas, CV of the gas produced over 1 kg of fuel. Okay, for example, we have here 1 kg of wood produces, this one, please correct in your notes, this is 2.5, not 1.5. 2.5. 1 kg of wood produce 2.5 meter cube of gas with average calorific value of this. Average calorific value of wood is this. Okay, so to find the efficiency, the conversion efficiency of the gasifier, CV of the gas over CV of the fuel. This is the calorific value of the gas. okay, which have been given, then the amount of the gas over CV of the fuel. This is CV of fuel. Okay, so from here, it can calculate the efficiency of the gasifier. Here, the efficiency of the gasifier is 68%. How to increase the efficiency? What do you think? How can you increase the efficiency? Any idea? Remove moisture. You mean using dry wood, dry biomass? How is that related? Low energy consumption. Okay, your point is to have to reduce the moisture, reduce moisture content. Okay, other than that, the rest, any idea how the efficiency can be increased? Higher quality of biomass. What do you mean by higher quality? Make sense? So it will convert it into more volume of gas. Right. Your point is now higher quality of biomass. Okay, make sense? How about others? Kamjarian, any idea? We must, if to have higher efficiency, so we need to increase the top part, right? So you need to think how you can increase the volume of the gas. This one is fixed. Average calorific value is related to the gas release. So you must figure out the gases produced, the volume of gases produced, and the type of gases produced as well. Okay. Okay, we are done on gasifier. Any questions? No question. I move to biogas. Biogas production. Where biogas production mainly we focus on the CH4. Okay, where this CH4 it should come from biomass. Okay, perhaps biomass or that contain CH hydrocarbon. Here, this figure is start from the polysaccharides, protein, and fats. Okay, here this one comes from, let's say, biomass waste. Okay, it undergone hydrolysis process. This hydrolysis process also it has few types of hydrolysis. You will have acid hydrolysis, alkaline hydrolysis, enzyme hydrolysis. There are many types. Okay, so the product from the hydrolysis will undergo acidogenesis, where from this part it will release H2 and acetic acid and also these few acids. From these few acids, undergone acetogenesis, where it will convert these acids into acetic acid and H2. Okay, then combine this together, both streams will produce CH4. This is the main product that is required. Okay, to convert those acetic acid and H2, it will undergo methanogenesis. This process involves the use of some microbes, okay, microbes or enzymes in order to convert those acids into biogas. Okay. Any of you have taken biochemical engineering? No. For the biochemical engineering, this part we will focus more on the types of microbe, how to take care of the microbe. So the detailed part will be on this part for the biochemical engineering. Okay, this one you can read through the detailed description for the biogas production. Now, this biogas production, example in palm oil mill. Okay, palm oil mill, where CPO is crude palm oil. Okay, crude palm oil. So the fresh fruit bunch enter the plant, you have CPO and obey as the waste. Pomade. What is pomade? What is pomade? Huh? Palm oil mill, effluent. Palm oil mill effluent. In oil palm industry, you will see a few abbreviation which is pomade, PKS, PKC, sorry, PKC. Okay, pomade is the liquid effluent. PKC is the solid sludge, palm kernel cake. Okay, so this pomade will enter the digester biogas plant. So now they are using the effluent, the waste stream. Okay, this is waste, waste stream. This is the main product, CPO. Waste liquid. The pomade is in liquid form. So this part is also waste, but in solid form. This solid waste, it can also be used as fuel to their combustion chamber and can also process to be converted into other valuable product. Okay, so from here, pomade enter the digester biogas plant. Here it will produce the biogas, CH4, the methane. Another stream will be the treated effluent. So from the waste enter the biogas plant, you will have methane as the main product. Then your effluent will be treated. So this treated effluent can release. Before release, need further checking on whether it meet the standard or not. Okay. Now, from this CH4, it will be used to fill up their generator set or their combustion process. Okay, so CH4 will be used locally, usually locally, inside their plant itself. So from here, it will reduce the energy consumption, reduce the fuel consumption if they need to buy the fuel. So let's say initially they buy the CH4 supply. When they have this digester biogas plant, the CH4 purchase will be reduced. So somehow it reduced their cost. Okay. Now this is example of a palm oil mill. This is focusing on the digester, where you can use, for example, over here is CSTR, anaerobic. The raw pomade enter the digester, so you will have this gas produced. The issue with biogas is the H2S over here. And some process will also produce ammonia. So these two gases are the major issue in biogas production. That's why you need to use, you need to maintain the growth of your microbe so that it reduces the H2S and ammonia gases. Okay. Any question on the biogas and biofuel? Now I move to fuel cell. You have gone through fuel cells previously in other subjects, right? Physical chem, in environmental engineering part. Nah. Physical chemistry, I remember last time I taught that subject. I also, this one is included in the syllabus as well. So fuel cell mainly device that generates electricity by chemical reaction. Remember the electrochemical series, the galvanic series. Okay, but fuel cells, it only involve H2 and O2. The in-fuel is H2 gas and O2 gas. Okay, and it generates electricity by chemical reaction. So this chemical reaction is depending to your anode and cathode and also the electrolytes. Electrolytes is the important part over here. Every fuel cell has two electrodes, okay, anode and cathode. The reaction produce electricity take place at the electrodes. Okay, every fuel cell has an electrolyte which carries electrically charged particles from one electrode to another. So in fuel cell, the important part is the electrodes, electrolytes. And of course, the gas, the inlet. Okay, there are different types of fuel cell. We have alkali, we have solid oxide, we will have molten liquid. We will go through one by one, but generally, all of those types of fuel cell, the difference is on the electrolytes. Okay, alkaline fuel cells, it use potassium hydroxide as the electrolyte, potassium hydroxide. So inside here is the electrolyte. It will produce hydroxyl ion, the OH. It will produce the OH. Hydrogen enters, oxygen enters, oxygen on the cathode, hydrogen on the anode. Okay, so from there, it's it will react with the electrolyte, then produce water, H2O. And of course, the energy, the electricity. The efficiency of these alkali fuel cells is around 70%. Operating temperature, quite low, 150 to 200 degrees C. Okay, the cell output is around 30 watts to 5 kilowatts. It varies, the cell output varies depending to the electrolyte use. Okay, the anode and cathode reaction, these reactions are general reactions for all fuel cells. Later on, you'll see different types of fuel cell, the reaction the same. It will produce H2O and also electricity. Okay, molten carbonate, where you will have different electrolytes. Here, use high temperature compound of salts carbonate, okay, as electrolyte. Efficiency ranges around this 60 to 80%, and it operates at high temperature. Okay, in molten carbonate, from this figure, you can see the inlet gases, apart from H2 and O2, it has CO2. Produce water as well, and also the electricity. Okay, for molten carbonate, you have inlet CO2. This CO2 react to form carbon trioxide ions. Okay, it will react with the carbonate salt electrolyte. So at the anode over here, this is the reaction. Since it used different electrolytes, so it will has these electrolyte ions. At the cathode, where it involves O2 and CO2, it will release the carbonate ion. Okay, this is MCFC. Now for the PAFC, phosphoric acid. Phosphoric acid. So acids, we know the source of H plus. Okay, so the electrolyte used to get the H plus. Operates at low temperature as well. At low efficiency range, 40 to 80. Okay, lowest is 40. Produce water as well. Okay, so these are the reaction at the anode and the cathode. For the PEM, proton exchange membrane. So this one they use polymer electrolyte in the form of a thin and permeable sheet. So they have for PEM, they have a thin film inside. Okay, a sheet of thin film inside. Operates at low temperature. Okay, this one is mentioned here. It is suitable for home and cars. So for the cars, perhaps they use this kind of fuel cell. Solid oxide use a hard and ceramic compound as electrolyte. So here they use ceramic compound. Efficiency is around 60% and operates at high pressure. These are direction at cathode and anode. These fuel cells, what you need to know is the different type of electrolyte and also its efficiency. 8 types of electrolytes. Efficiency and also its operating temperature. Because each fuel cells operates at different range of temperature and has different range of efficiency. So from there, you can conclude which one has the highest efficiency. Okay, as we go through, we have solid oxide 60%. Phosphoric acid can make up to 80% from here. MCFC can reach up to 80% as well. Alkali 70%. Okay, from the slide over here. Now we have MCFC and also the phosphoric. We have 80%. Between these two, this one, which one is more sustainable? Okay, you check on the temperature involved. For PAFC is around 150 to 200. MCFC at higher degree C. Okay, so to have similar efficiency at 80%, with low temperature, we will go for PAFC because it has lower temperature. Okay, so from here we can conclude that PFC has high efficiency with low temperature. And if you notice, the cell output also has high energy, high kilowatt. Okay. Now you need to know each of these fuel cell applies in which type of industry. Okay, let's say PFC. Try to find out what industry use this. Okay, so those are the types of fuel cells. This thermodynamic analysis is basically the general principle of the fuel cells. You will have hydrogen, oxygen as the inlet gases and produce electricity, heat, and water. The main target is the electricity. From the fuel types just now, we can conclude the PAFC has the higher efficiency with low temperature. Okay, this one I will not go into details. The polarization curve and also the energy. Okay, basically the cell reaction from the anode and cathode, which involve the oxidation and reduction. So these are the overall cell reaction. This one you must take note. The oxidation half reaction and reduction half reaction. Conclude by the overall cell reaction. You take corrosion? No, so. Okay, this one, I will not focus much this. The thermodynamic, this one, the energy. Fuel efficiency. We just focus on the types of fuel cells. Okay, now we still have 100. Okay, now I'm going to do some exercise where you summarize the information of each fuel cell according to the category. Okay, this one I already did one example. Type of fuel cell, example alkali fuel cell. So the description, how is the description of this fuel cell? It has hydrogen, oxygen, okay, use potassium hydroxide as the electrolyte. You find out the advantage and disadvantage, okay, for each fuel cell, and then the application. Okay, I found out this alkali fuel cell being used in this type of industry. Then put out your reference. Okay, I have done alkali fuel cells. You can take other fuel cells. Take one per person. Then snap the picture of what you did. Send to team chat. Then I will project over here. If you write on paper, snap the picture of it, send to team chat. If you use your tab, you just directly send it to team chat. Here we have MCFC, PEM, PFC, and solid oxide. 4 more. Take one each. 1 cell per person. Okay, I received only one as of now. The rest, please submit by today. You must submit by today as considered as attendance. In through team chat. My personal team chat. Have you submitted? Okay, through my team chat. Latest by 5 p.m. today. Okay, that's all. Thank you. Remember for next week, Tuesday, please join the program. I will put the detail in CN.